we actually start, and before we go into the slides, so I want to welcome you in week 2 of the Kubernetes Month, where we talk about networking in Kubernetes or Kubernetes networking. So the same thing. So this is a part of the Kubernetes Month, of course, as you all know. So last week we had the session talking about concepts of Kubernetes or Kubernetes cluster, and I'm just giving here a recap of what we said last week. We demonstrated the components of the Kubernetes cluster, which is control plane, the brain, as we want to say, and the worker nodes, which are the body or the rest of the cluster. We also specified more than that, so we're not going to go too much into it. This session, we're going to talk about 7 things or 6 things. The last 2 are just practice. And yes, of course, we're going to have a lab and we're going to talk about what's going to be in the next session. So today's practical demo will be demonstrated by a speaker, and we're going to talk to Maulik when we get to that part. But we have, as I said, we have 6 topics we're going to talk about today. And the first one is why Kubernetes networking matter. So the last session we understood the concepts of Kubernetes cluster and all of that. And this session we're going to understand how do they communicate with each other, how applications communicate with each other, what is the difference between service and Ingress controllers, and how do we use them. Also, we're going to talk about networking basics in Kubernetes, and we're going to also talk about networking basics, but not in Kubernetes, so we can differentiate between the Kubernetes mindset and actual networking mindset, and both are different. Both are networking, but both follow a very different scheme, let's say. And then the third index is going to talk about pod-to-pod communication. How do pods communicate with each other? How we do not have any hand in that, so we don't configure anything. It's just something that is built in. And then in index number 4, we're going to talk about services explained and Ingress, and we're going to add to it Ingress controller. And then at number 5, we're going to go through like a workflow on how traffic goes from end to end. So how does the traffic flow inside a Kubernetes cluster? And then we're going to talk very shortly about common networking pitfalls. So something you may have assumed during the session, we're going to talk about it, what's right, what's wrong. And then Maulik is going to give us a very practical demo overview on how we can create services, why did we choose certain type of things. Of course, I'm not going to go into that. And then we're going to do a quick recap before we end the session and explain what's going to be in our next session, that is next week. So first thing, why Kubernetes networking matter? Would anyone have an idea on why actually Kubernetes or understanding the Kubernetes mindset actually matters before I actually go into the slides? Also, if anyone wants to answer via chat, they're welcome to do that. So why it's really important to understand Kubernetes networking. I'm going to give you all a minute to think about it. Please don't use ChatGPT. I want wrong and right answers. I want to see what you can guess. More flexible and scalable. It is more flexible and scalable, but it has its limitations, not scalability-wise. So, okay, good answer. Let's go to our first. Slide. So, Kubernetes networking, why Kubernetes matter. Of course, it's Kubernetes networking is what actually makes your application live. So as you saw in the, because we have so many parts, maybe we have too many parts, maybe we have to deal with the internal and external networking. So kind of true. And we have the last answer, to allow traffic flow within the cluster and out of it. Yes, exactly. That's a very good answer, actually. Okay, so why Kubernetes networking matters? As some of you answered in the chat, it's because it allows us to understand how traffic flows inside of the cluster and outside of the cluster. So in the last demo, I made an application that was only reachable via local host. If you remember, I had to forward the port and IP, so it can be reachable from local host, even though. So if it was on local host, no one can access it except this computer or my computer or myself or your local host, let's say. So if we want to make our application live, حابين انه نعرض الابلكيشن تاعنا على الانترنت to be accessible via everyone, we need to actually understand how Kubernetes networking work. We need to understand the concepts, the types of ingresses, the types of ingress controllers, the type of services. We need to understand what's the best thing to use. And all of them, so every type of service has a cost associated to it. And we have actually a session in February 15th that's gonna talk about why Kubernetes may cost more than you expect. So we're gonna talk more also about the cost aspect of it. Okay, so let's read what's in the slides. Kubernetes networking is what connects your application to the world. Application don't fail because of code alone. Of course, in the previous session as well, we said that sometimes bad code, bad design will not work on Kubernetes, but even good code and good design doesn't work on Kubernetes if you actually don't understand the concept. So you have good code, you have good application, and I'm gonna give you a very important line. I want you to memorize later on. So most production issues are caused by traffic routing, service exposure, or misunderstood networking behavior. And understanding Kubernetes networking is what turns YAML file into real, reliable system that users can actually reach and use. I think that sounds great. So, networking basics in Kubernetes. Before we go any further in Kubernetes, I want us to step back a little bit and understand traditional networking and NATing. So, in every network in the world, we specifically using IP version 4. There is not a lot of public IP addresses. This is why they created IPv6. So we only have like a couple of million public IPs, and we have 3 classes of private IPs. So, Malik, do you want to say anything?
Hello, everyone. So, yeah. Yes.
No.
So, mine, I just say it's an.
Yeah.
Okay, Maya. So, can I start, right?
No, sorry. Malik Nasser had his mic open, so I thought he wanted to share something.
Okay. No.
So if we want to step back into traditional networking, we understand that not all devices inside a certain home, certain company, are exposed to the internet. So we have these phones, we have these laptops, we have these TVs. Not all of them have their own public IP address that can connect them to the internet. But what they have is their own private IP address that keeps all these devices connected to each other. And then the router is gonna have all of these private IP addresses stored in him. And then he's gonna deliver the message on behalf of the public IP inside the router. So NATing, let's say. Of course, NAT, which is a network address translation. So if you want to send any type of message to someone, it goes from your phone to the router and then to the other side. Not just directly to the other side, it also goes in a bunch of routers, his router, and then his actual device. So it doesn't just go to his device. So in traditional infrastructures, applications usually live behind a NAT, and servers or virtual machine uses private IPs. While a single public IP address represents them to the outside world, NAT hides the actual internal addresses and controls traffic flow and requires port mapping or load balancers to expose services externally. So, if you can think of it, like all of the devices, all of the laptops, the phone, the TVs are connected to one router, and this router connects them to the internet or the world, let's say. So basically, this is like a visual workflow of that. So we have the internet, we have public IPs, and then we have traffic flow, and then we have the NAT gateway or router, and then we have our server or VMs. Of course, we're not going to talk about the difference between public and private IP addresses. If anyone is interested, we can do a very basic networking session later on that does not have to do anything with Kubernetes. So if we go back to Kubernetes, which was our actual topic of the day, in Kubernetes basics, it's actually different. It's different than this whole natting thing. It's not so different. It's just a very different mental model, as you can see here. Oh, sorry. So as a result, networking in Kubernetes is simpler at scale, but require a different mental model. And this is the line I was telling you about that you need to keep it in your head. So Kubernetes, it's simpler, but it needs a different mindset, not the traditional one that we're used to have. So in Kubernetes, each pod is assigned to its own IP address, of course, and it can directly communicate to other devices without using a NAT. So all pods inside of a cluster can communicate with each other, and each pod has its own IP address. Of course, if let's say if you have your own network, you have to connect each device together. If not, it has to communicate to the router or switch, and then it's gonna communicate back to you. So if actually the pod the in the traditional networking, if the devices are not directly connected to each other, it needs to have like something in between so it can communicate from point A to point B. But in networking and in Kubernetes, actually the pod can communicate with each other, and there is no problem in that, and each pod has its own IP address. And if you can see, this approach actually simplifies application to application communication because pods can communicate with each other, no hassle. And but it also introduced networking concepts that are very different from traditional or VM or server-based environment. So this is really different from what we're used to have when you're hosting your application on a server or on a virtual machine or on an EC2 instance. Pods and Kubernetes deal with networking in a very different mental model. So let's talk more about our pod-to-pod communication, because in the previous slide we have said that pods can talk directly to each other, but the problem is pods are temporary, they're ephemeral. What do we mean by ephemeral? It means like we can give it like an example, the RAM and the ROM. So ROM is a random, is it random? Read-only memory. Yeah, it's read-only memory, sorry. So read-only memory, or the ROM, or the operating system you have on your device, even if your computer turns off, you're still gonna have it. It's not gonna go away. So for RAM, which is random access memory, it's ephemeral. So if you have this Word document that you have not saved and it's saved on the RAM, and your laptop turned off, of course we all of us had this type of incident, it's gonna go away, it's gonna be deleted, it's not saved, so you're lost. So ephemeral actually means that if you turn on the switch on something, turn off the switch on something, it just goes, it's not saved, it's just saved temporarily, let's say. So in Kubernetes, pods can communicate with each other directly using their IP addresses, even when they're running on different nodes. Okay, so pods can communicate. So let's go back a little bit. We talked that we have a cluster. Inside of cluster, we have nodes, and inside of nodes, we have pods. There is, of course, more to that architecture. Like above pods, there is namespaces. which separate each project alone. So we're gonna talk about it in the demo, by the way. So even if you have pods in different nodes, they can still communicate with each other. And this direct connectivity is a core assumption of Kubernetes networking and is provided by the cluster's container networking interface, a CNI, or traditionally we call it ENI on AWS, or NIC, a NIC card, network interface card, or elastic interface network. ENI, elastic network interface. Yeah. So, from application point of view, the network behaves as a single shared network rather than isolated machine. So, in virtual machines, each server was considered as different machine, a different network, but inside of a pod, the application acts like it's just a one bit, and internally everything happens, but externally to an application, it's just a one network. So, as we said, pods can directly talk to each other, but pods are temporarily, which this is going to bring us to the next option or the next index, which are services explained. So, we said that pods are ephemeral. They're temporary. They can't stay. So how can our application be stable if we have an application on a pod or a container on a pod, and then it just flies away? So services actually give that stability in a world where pods are intentionally unstable. So what does that mean? Services is actually what gives pods or application, to be more specific, their stability. It's not pods. Pods were never stable. Pods are made to be removed, replaced, cloned, let's say. And pods in Kubernetes, as we said, they're ephemeral. So when you turn off the switch, they just go without saving anything. They can be created, destroyed, rescheduled at any times, which means their IP addresses are not stable. So you have to like, this is one of the common pitfalls that we're going to talk about, is you using the pod IP address, which is ephemeral. So that's a big no. Services exist to provide a stable network endpoint that consistently route traffic to the correct set of pods. So a service is like an entry point, a gateway, let's say, or a place where it takes all of the traffic and routes it to the place or the pods that needs to be routed to. So services enable reliable communication between apps, and even as the underlying pods change. So if someone has an idea about AWS auto-scaling group and load balancer, so if a load balancer communicates to talks to an auto-scaling group, it doesn't matter if your virtual machine is down or up. What matters is this load balancer talks to an endpoint, and this endpoints ensure high availability and reliability. So we have 4 types of services. Sorry. The first type, and which is more common, the more common one, I think. Can we yeah, it's very small. Okay, I think this is good. Let's go with the first one. Let me make it a bit bigger. Yeah. So the first one is ClusterIP. This is the default service type, and this is a keyword. So ClusterIP is the default service type that is used between pods. Okay. It's a service type, and it's the default service type, and exposes an application only inside the Kubernetes cluster. Again, only inside a Kubernetes cluster. So you need to understand that ClusterIP only works inside of a cluster. It provides a stable internal IP and DNS name that other pods can use to communicate with the service. ClusterIP is commonly used for internal microservice and should not be accessible from outside of the cluster. So we understood the first type should not be accessible outside of the cluster. It only meant for inside of a cluster task. So on the contrary, العكس تماما, we have NodePort, which exposes a service by opening a static port. So as you know, we have HTTPS port, which is 443, or HTTP, which is 80. We have Prometheus, I think, or Grafana, which is 9090 or 9100. We have cluster IP name is deceiving. It's not. It's like cluster IP inside of the IP, you know. So NodePort, as we said, it just exposes a port to outside of the cluster. So on the contrary of cluster IP. Um, of course, it's mainly used for testing and demos, and it is not recommended for production. Of course, if you have any kind of legacy application, and all legacy application used to have port-based routing from front end to back end, and this idea is now changing. So instead of ports, best practices is to use a host name. So um instead of like tenant A having a 333, for example, port, it can have tenant A at company.com, for example. So NodePort still used for testing and demos. It's simpler than using a host name. It just exposes one port or multiple ports, and it can be accessed via the external external users. So the next service type we have is the load balancer, which exposes a service externally by provisioning a cloud provider load balancer, and this is what typically is used with a cluster or Kubernetes cluster that is hosted on cloud and used for production. So we said cluster IP only works internally between pods. We said NodePort is used for demos and testing and only can expose ports. And we have load balancer, which is the third type. This type uh, provisions a cloud provider load balancer. It creates a public entry point that forwards traffic to the service and its cluster. So this load balancer is like a node port, but instead of actual port, we have a cloud provider load balancer, and it's an external entry point inside of the cluster. This, as we said, this approach is commonly used in Kubernetes environment and in production. But if you can actually read the last line, but can increase cost. Yes, it can actually increase cost using the load balancer. And the fourth and last one, in services, we have external name. So external name maps a service to an external DNS name instead of routing traffic to pods. It does not create IPs or perform load balancing. It is mainly used to integrate external services into the cluster. So external name is different from all of them. It's just it maps a service to an external DNS name, and that's it. So if you want to connect the load balancer, instead of actually using like aws.loadbalancer.com, for example, you can actually use a host name for it. So a quick recap, we have 4 types: cluster IP, node port, load balancer, and external name. Okay, so we talked about services, which routes traffic to cluster or inside of the cluster, externally to internal or internal to external. So we understood that services have the capability to route traffic, but who writes these rules? Who understand where should it go? What components should it use? What's allowed and what's not allowed? Who writes these type of rules? It is the Ingress, my dears. Ingress allows us to do that, write rules, and Ingress controllers abide these rules. You have to do these rules. It controls these rules. And services, it just routes traffic from A to B or B to Z, whatever. Okay. So Ingress in Kubernetes resource that define how external HTTP and HTTPS traffic routed to service inside of the cluster. It allows you to expose multiple applications using a single entry point. So, similar to route tables in AWS, you can actually say that yes, it's similar to route tables in AWS, Yes. Okay, so you can expose multiple application using single entry point, which is a very good practice. Instead of you having to manage multiple entry points, you only have one entry point, and this entry points can route traffic, which is a service that can route traffic to the traffic where it needs to be headed. Okay, so as you can see here, the application Ingress works at the application layer and focuses on routing rules rather than direct traffic handling. So it doesn't handle traffic, it only has routing rules, and that's it. So Ingress controllers, I don't want to like read all of this. It enforces the Ingress rules. As we said, it abides the rules. So this line right here is what's important from both slides, which is Ingress is just configuration, it's just rules, and the Ingress controller does the real work, and that's it. It actually enforces this. And as you can see here, this line right here, without an Ingress controller, Ingress rules have no effect. Okay, so you have the rules, you need the effect. This effect is gonna be taken via the Ingress controller. So I think most of you guys, uh, this is an extra thing because I've seen it on LinkedIn a lot lately, which talks about Nginx Ingress, which is retiring, and Kubernetes Gateway API, which is the future. We're just gonna go over them very quickly. So Ingress is not deprecated, Nginx Ingress is not deprecated or disappearing tomorrow. It's still used by production today, and I don't think it's gonna be going anywhere soon, but the support is gonna stop on it. And they're having this new Kubernetes API, Gateway API, but Gateway API is where Kubernetes networking is headed. Okay, give me one moment. Okay, so this slide is just like a quick heads up that we're no longer using Nginx controllers. We're hopping on something new that is called Kubernetes Gateway API. Okay, so traffic flow end to end from point A to point B. How does the traffic goes? As you can see here, I don't want to like read all of this. I want you guys to look at this diagram. So we have the internet, and then the internet goes to the Ingress. The Ingress and the Ingress controller have the rules to set this up. And then the Ingress routes it to the Ingress controller, routes it to the service, and then the service decide which pod it should go to. So as you can see at the end here, Ingress decide where traffic goes, and services decide which pod gets it. Okay, so does anyone have any kind of question till now? Okay. Clear. Thank you. Okay. So the last index we're gonna talk about, which is common networking pitfalls. So if traffic isn't working, it's usually network. If traffic, I'm not saying the whole application is not working. I'm saying if traffic is not working, it's usually configuration and not the code. So keep that in mind. So the first thing we have is accessing pod directly. So as we said, pods are ephemeral, and it's never a good idea to use the pods IP addresses in any kind of endpoint. So don't use pods IP addresses directly. Using the wrong service type. So if you chose ClusterIP when you wanted a load balancer, that's gonna be a very correct decision to make. So you need to check all of the requirements that you need, and based on these requirements you can choose your correct service type. expecting Ingress to work automatically. Of course, you have to configure it. You have to have an Ingress controller to handle traffic. So Ingress doesn't work alone. Ingress are just rules, and as we said, controllers which make enforces these rules. And confusing services with Ingress. This is a lot of. It happened to me, to be honest. I was, what is the difference between an Ingress and what's the difference between a service? But as we said, services route traffic to pods, while Ingress controllers are external access. They just have rules and that's it. Hard coding IP addresses, and that's a big no-no, as we said, because it can change. It's intentionally made to be unstable in terms of IP addresses. Yeah. Okay. So, and now we're just gonna take a 5-minute break. I'm gonna stop the recording now. Should I stop? Are we gonna take a 5-minute break? No, don't think it's worth it. Okay, so we're gonna start actually with a practical demo, but I need to make sure that um, he can share his screen and start. So Malik, are you with me?
Yes, I am with you right now.
Yeah.
So it's still.
Yeah, I'm gonna stop my share. Can you share your screen now?
Oh yes, yeah. It's giving me the option to share my screen.
Yep. Okay, guys. So I'm gonna start the demo, and Malik is gonna be demonstrating the practical part of our demo today.
Okay, my screen is visible to everyone.
Yes, you can share your PowerShell if you want.
Yeah, this one. Okay, so we can start to practical how the networking is working with the in the Kubernetes, what Miles explained before. Okay, so let's start with the configurations what we have right now. Okay, so we have the two nodes here, right?
I
First
think
is
Malik, I think you need to share your PowerShell. We only can see the yeah.
okay. Okay, but in from mine, so it will showing the single screen. So it's for Windows. Okay, now it's getting shown.
Okay, you can I think check the Windows tab. Yeah, yeah,
Yeah, now it's fine, right?
yeah. Now it's good. Go ahead, proceed.
Okay. Okay, so this is the one like we have the two nodes here in the cluster. Its first one is for control plane. This is managing all those configurations like scheduling and all. Another one is this desktop worker. So it's a worker node that will this expose this applications and containers is running on the worker node. So here we can create the namespace first. Okay, so this is how we can create the namespace to expose like the container creating in the namespace after that. It's a netlab. So we can check it's in the namespace is created or not. Okay, so here it is. You can see it's a netlab. This one is created and it's ready to use. And now we can just make sure that we have to just check those like how we can create the containers. Okay, so I just explained those like how we can create the containers from the pod. Okay, give me 1 minute. I just switch to my screen. Okay, so now you can see that this is the YAML configurations for the pod container creation. This is basically it's an Nginx pod, right? So that will Nginx pod container it's created and that will run internally. But after that, we can expose them to the services on the cluster IP, what the Maya is explaining before. Okay, so this is the configurations. It will run on a port 80, and this that will use the Nginx image. Okay, so and it will connect it to the namespace netlab. Okay, what I'm creating before. So now we can jump onto that, and we can create the container from this file. That is the command that we can create the container. Okay, so now it's going to ready to use that container, and we can just make sure that that container is created in the NetLab namespace. Okay, so you can see that it will create in this namespace, Nginx board. Okay, so now we are just going to check that that application, like that board is running or not. Like we are getting any curl commands, like, so we are going to check that Nginx board is working fine. That will show only the container is running. So how we can going to check that, is it running in real labs or not? So for that, I just share to those commands like inside them. Okay, so I can make sure, like, show you that how we can check those containers is running fine or not inside to login in the container. Okay, you can see that this is the command, like, where we can log in the Nginx board, and we can check localhost. Like, that means it will running locally. Okay, now you can see that this is the Nginx default page that will show you that Nginx board, like the Nginx page is running properly, and it will run in the container. Okay, so this is how we can just do that configurations for the port. Now we can jump on to the services part, like how we can route those traffic to the cluster IP. So cluster IPs works fine when we are going to check over the cluster IPs. Okay, so that's how we can do that. So for that, I just show you that the the port dot services dot YAML file. Okay, Maya, can you see that my file? Hello, hello.
I'm sorry, the cookies sign is over the mute. So yes, we can see your file.
Yeah, this one. It's in service.yaml file where
Yeah,
we are going to expose that containers
yeah,
in the cluster IP. Okay.
yeah.
So now I'm going to create that service part. It's in queue.
So you want to share now your PowerShell screen, right?
Yep. Oh yes, I'm just sharing my PowerShell screen now. Okay. Is it visible, right?
Yes.
Okay. Now I'm going to create that services part. Okay, so that means it will create, but we can make sure that it is created or not. So we can check here. Okay, you can see that file is created, but it's not for the specific one. So for that, I will show you that the particular file is created, and it will get accessible from the services part. Okay, so you can see that this service is created in that. This is the by default services for Kubernetes cluster IP, but we are going to create for the specific port, like for 80. So this is the cluster IP. It will create it by service.yaml file and Nginx services. Okay, so it will, that means like it's getting created and it will works fine. Now we can check like how we can just access it, that services through that. We can just testing those service networking inside the cluster. So that one we can do that. So we can make sure that it will get accessible from that cluster. So this is how we can run those test client over there. Okay, so that means it will going to log in inside that container through that service. You can see that we are in the containers. Okay, and inside the container, we are going to access that Nginx services. Okay, so now you can see that the same we can just accessible through this service. So this is how the Nginx service is working here. Okay, so that's it from mine. So you can just make sure that they will just working or not. So
So
mine you can just take
yeah,
it easy.
so I wanted to ask if you can give us a recap of what you did. So you created two files.
Correct. Yep.
Uh, yeah, and then you can tell us the recap. So you created two files, and then you did what?
Yeah, I can create two files. First file is for port container, right?
Yes,
It's a port for the container, and another file is using for services. Like we
yes,
can create a specific services to access that page, right? So access the Nginx port,
yeah,
right? So they will just specified for from the within the network, right? So we can create one specific service. That means it will accessible through that service. So that's why we can create another file.
yeah,
That file is a YAML file, and we can check like before the service is created, we can just access that page like the Nginx through the port. So that means its port is working
yeah,
internally, right? So, but from the another side, we can create. We are just going to create a service like ClusterIP. So we can check that going to login inside the inside the container, right? And inside the container, it will works inside the container as well. Like it will just working what it outside before.
yeah.
So that is the thing what we are doing. The same process, but we are going to create a service, and service is going to create those container, accessible container through that
Yeah.
service.
Okay, well, perfect. Thank you, Malik, for giving us the practical part. I really appreciate it, and it was really great. It
Yeah,
made us understand why do we actually need to use a service.
yeah, yeah, Maya. Thank you for your help and for your assistance for that.
Thank you. Okay, so guys, let's continue. So our key takeaways or quick recap that we are gonna say: Kubernetes networking is very different than what we actually are used to. It's very abstracted, doesn't deal with IP addresses and all of these hard to understand internal communications. So by understanding how pods, services, and Ingress controller work together, you can design applications that are reliable, scalable, and um, easier to debug. So, does anyone have any kind of questions on networking in Kubernetes before we go on what's next? Yep, DNS domain. Okay, so Hamad, DNS domains or domain name system are a very different topic, but briefly, it is a server that translates IPs to hostname. So if you know, let me share my screen on a very different tab. So I'm gonna share my screen on this tab. Hopefully it works. Okay, so if I wanted to actually put google.com, it's gonna give me google.com um, tab. And if I entered the IP address, which is 8888, this is the primary IP address for Google. So if I entered this in the uh, if I entered this in the uh, if I entered 8.8.8, it's gonna go ahead and put me to dns.google. So let's say if I want to check on AWS Resolve, you can see here that it gives you all it's gonna give you all of the things you need to understand. So um, a DNS is very basically, it just translates IPs to whatever you want, .com, .net, and everything else. Okay, so how to implement domain with pods using services. You need to use external name, as we discussed. You need to write an external name.yaml file, and you can like use the external name to route DNS domains to services or application inside Kubernetes cluster. Or you can just use a load balancer. Like I used to in the application we used to have an ELB, which is an AWS Elastic Load Balancer. And when you create an Elastic Load Balancer, it gives you a URL like AWS dot the numbers of your AWS account and dot load balancer maybe in US East 1. So you take this URL and you embed it inside of the Ingress .yaml file. Okay. So any other questions, Hamad, before we go to what's next? Thanks. Okay. So what's next? Of course, we took 2 sessions. The first session was about Kubernetes cluster, as we mentioned. The next session, or this session, is about more into networking and how networking works in Kubernetes. The next session is going to be about observability in Kubernetes. So we're going to talk about a different service that we connect to Kubernetes, which is Prometheus and Grafana, hopefully, or just Prometheus. I still don't know. I would believe it's just going to be Prometheus. We're going to leave Prometheus and Grafana in detail for another session. So if anyone is interested, let me stop the share and stop the recording, sorry, and then we can have a little discussion. So what's next is going to be our observability session, and thank you guys for joining.